Hello guys, in this video we are going to solve this problem. This is our first problem in this series. So let's see what is the problem. So for positive integers n, we define f of n in this way, like n plus 16 plus 5n minus 3n square divided by 4n plus 3n square plus 32 plus n minus 3n square divided by 8n plus 3n square, and so on. The last term is this. And we have to find out the limit n tending to infinity f of n. Let's see how we can do this. So first of all, you see there are different types of terms here, and the procedure to solve this problem is you find the general term in some variable, let's say r, and then you solve this. So find some pattern in these terms and make a general term. If you see f of n, I write this in this way, like n plus summation r is equal to 1 to n, and then this thing, which is 16 times r plus 9n minus 4nr minus 3n square divided by 4nr plus 3n square. So let's see. This n is coming from here, and now you see the pattern, like here it is 16, here it is 32. Here it is 48. So this is just increasing like in this way, 16 multiplied by 1, 16 multiplied by 2, 16 multiplied by 3. So that's why I write here 16r. So if you replace r, then if you replace r is equal to 1, then you get 16. If you replace r is equal to 2, you get 32. If you replace r is equal to 3, you will get 48, and so on. Next, you see this is 5n, this is n, this is minus 3n. So you see it is decreasing by 4n. It is starting from 5n and then decreasing by 4n, then come n minus 3n, then minus 7n, and so on, so on. So here the term is 9n minus 4nr. So if you put r is equal to 1, then you will get 5n. If you put r is equal to 2, you will get n. If you put r is equal to 3, you will get minus 3n. So in this way, this term is coming. And the last term, if you see in the numerator, it is minus 3n square here. Also here minus 3n square. Here it is also minus 3n square. And in the last, it is minus 7n square. So this term is minus 3n square here. And if you see, like how the last term is coming, so if you put like r is equal to n here, so it will come like 16 times n plus 4n minus, sorry, 9n minus 4n square minus 3n square. So it will coming as 25n minus 7n square, which is the last term's numerator. So in this way we are also getting like we have to go up to r is equal to n, then we will get the last term. So in this way the numerator is forming like this. And in the denominator, if you see, the first term is 4n, then 8n, then 12n, and so on, and the last term is this. So you make general term this 4nr plus 3n square. So if you put r is equal to 1, then you will get like 4n plus 3n square. If you put r is equal to 2, you will get 8n plus 3n square. If you put r is equal to n, then you will get 4n square plus 3n square, which is 7n square. So this is the last term. So in this way we find out that this is the general term that is working for the terms given in the problem. Now first we find out the general term, and what we can do, we can take this n inside this summation, and how? So this will come inside in the form of 1. So if you add 1 n times, so it will come as n. So if you add 1 n times, so this is 1 1 1 1. So these we are adding n times. So this will give us n. So we can and because this one is independent of r, here we are varying the r, and this is independent of r, so we can say that the one term will come n times, so this will come n. So this is this term which we are moving inside the summation. and our the general term is this, then what we can do, you can take this base as common, and then you can see this. After taking this base as common in the numerator, this thing will form. So here these two terms will cancel and only this thing will remain, and we have this summation r is equal to 1 to n. Now you see, if you see this, you can take this n outside in the numerator, and the n square outside from the denominator, and here it will form r by n, and here it is 1 by n. So if you take r by n to the x, then dr by uh, n will form the dx. So this is the like the formation, and if you take limit n tending to infinity, then this is the equivalent of this integral, like this. If you see, you have read this concept somewhere, like this is the thing which is equivalent to this integral, 16x plus 9 and divided by 4x plus 3 and dx. So I replaced r by n uh, by x, and this r by n by also x, and this is 1 by n here, and this will form this dx, and this will come in this way, and we have this integral from 0 to 1. So like if you put here like r is equal to n, then it will come like n by n which approach 1. So in this way this integral will form. So the summation previously, which is this summation, it is same as this integral. Now you can easily solve this integral. So you can write this 9 as 12 minus 3, and then you can see here this will come in this form, like 3 minus 3 divided by 4x plus 3. Now you can easily do the integral, and this will come in this form, like 3 times x minus here it is 3, and we can take 4 to the outside. From here, if you take 4 to the outside, then it will simply come like ln of x plus 3 by 4. And the integral is, so here actually this will come as 4. Because if you see this 16x plus 12 divided by 4x plus 3, it will cancel 4 times. So here it will come like 4. So there is a mistake here. So we can write this as 4 times x minus 3 by 4 ln of x plus 3 by 4. So this is the integral of this thing, and we have to put the limit from 0 to 1. So if you put then it will come like if you put 1, it will come like 4 minus 3 by 4 ln of 7 by 4, and if you put 0, this will come in this way. And if you combine these two terms, then you can see there is the difference of ln, so it will come in divide, so it will come like 7 by 3 here. So if you see, the answer is this B option, which is 4 minus 3 by 4 ln of 7 by 3, and in this way we can solve this.